I get like too much stuff.
Number 12. Somebody help me out and read it to me.
The relationship between A and B, if AB equals 1.
It says make a conjecture about each value or
Oh,
geometry.
A times B equals 1. So we want to know, you got some number A, this is number 12, you got some number B, and they're saying A times B equals 1. What's that tell you about A and B? They're both 1? That could be. Is that the only thing that works?
Or negative.
Or -1 and negative, they're both -1?
2.5. 2.
So 2, so these are, you guys are giving me examples, so we got 1 times 1, that works, right? -1 times -1, that works. Kellen just said 2 times 1/2, that works. We want to make up a conjecture about this, some statement about what we know about A and B.
They both have to be.
Do they have to be the same? Because Kellen just showed
Oh,
us
yeah.
one where it's not, right? What do they have to be to each other?
Oh, both have to have the same sign.
That's true.
Um,
Anybody remember from algebra, from earlier math classes, what it's called when you have something like this right here?
opposites.
Opposite would be like,
Function? I don't know.
opposite would be like -5 and 5, right? Right idea, wrong name. Come up with another one. What's another one that would work?
But, yeah, that, right?
That Kellen had the right idea. This is where you need to be looking. It's dealing with the fractions, and that's why you guys are having so much trouble with it, because how much do you like fractions? You don't like them at all, do you? So somewhere along the line, I know in algebra you did it, especially if you had Mrs. Barnes, because she was just talking about these properties the other day.
3 times 1/3.
3 times 1/3. 4 times 1/4. Now, I'm not writing down any more that's like that. Come up with 2 fractions.
4/1.
Oh, that's the same as this one.
Yeah.
What happens here?
You like do the thing where you like cross multiply.
No, what happens? What do you notice about this number and how it relates to that number?
It's the reciprocal.
It's the reciprocal.
What is the
That's what we wanted, not opposite reciprocal, just the reciprocal.
What is the reciprocal?
So what is the reciprocal?
It's
Give me some fraction, not one of these.
3/2.
3/2. What's the reciprocal of 3/2?
2/3.
2/3.
Oh.
If I multiply those two together, what do I end up with? 1. So what do we know about A and B?
There was
A and B must be reciprocals of each other. Reciprocals of each other. Did you learn about reciprocals last year? Yeah, as a matter of fact, you learned that property. I know I was just looking at Mrs. Barnes's, she just had her notes in something, in a meeting that we had to go to, and she had all these properties that she had listed. She might have, I think maybe I thought she was making, I can't remember, she might have been making a flip chart or something that we won't do in here, I'm not that creative, but she's making a flip chart of the things. She likes doing all that stuff, I'm not. I'm sorry, I'm more Karen, you get unlucky if you don't like it. I guess you go to another school or something, or stay around in geometry till I retire, and then they might be more creative, but I'm but they gotta be reciprocals of each other. Kellen or somebody said opposite reciprocals. That's something you learned last year also in not in geometry, in algebra, but we're gonna learn it in geometry also. If things are opposite reciprocals, that means when you have two lines, if they're opposite reciprocals of each other, those two lines are this to each other. What's that symbol? Perpendicular. Means they come together to form right angles, 90 degrees. So if things are opposite reciprocals. So if I gave you a fraction, somebody make up a fraction for me. 1/8. What's the opposite reciprocal of that? -8 over 1. Those are opposite reciprocals. When you multiply them, do they come out to be 1 like this one did? No, they come out to be -1. But when you have slopes of two different lines, and they look that way, then we know those two lines are perpendicular, and that's a rule we're gonna learn down the road. But this is what could say on that one. Next question.
Oh, 16.
16. Relationship between the volume of a prism and a pyramid with the same base and equal heights. Anybody remember what was the formula for volume of a prism? It was just one of them that we had was big B times H, right?
Yeah.
Now, look in your notes there, what was the volume of a pyramid? Somebody see if they can find the formula for volume of a pyramid. Volume of a pyramid, it's one of the formulas we had in the 3D stuff. Just get your binder all fixed up, Jacob.
No, I'll do that. Make intervention or something.
So you got it sorted back together. Is there a formula? I think we had a formula for pyramids, didn't we?
Yes.
So volume,
1/3
B times
B times H,
1/3 big B times H.
yeah.
So we're looking at these two formulas. This is a prism. This is a pyramid. What do you notice?
pyramids divided by 3.
Exactly. So, and we probably wrote it down, instead of writing down this one, we probably wrote down big B times H divided by 3 to make it easier, right? So, if we have a prism and it has the same base and the same height as this pyramid, what do we notice about the volumes?
It's the volume of the pyramid is going to be
Volume of pyramid is what?
1/3 of
1/3 of the volume of the prism. So if I have some prism, that's my prism, and this base down here is 10 by 5. Then I have some pyramid, and this base down here is 10 by 5. And their heights were the same if I would have drawn them a little better. And their heights were the same, then we know that this volume is 3 times as much as that volume. Or vice versa, this volume is 1/3 as much as that one. But this is the conjecture they want you to draw. What's a conjecture again?
statement.
Just any statement, anything. Now, our statement here happens to be true. Conjecture always have to be true?
No.
Other questions? Number 28. Adric made the following pattern by connecting points with line segments. 28, right?
Yeah.
So the first one looks like this.
Just a regular triangle.
Trying to think if I showed you the whole
Is that right? Is that what he's got? Suppose Adric continues the pattern, how many line segments will he need to make 4 triangles, then 5 triangles? This is part A. So we got, how many triangles here?
one.
1, how many segments?
Three.
So notice what I'm doing here. I'm just writing triangles on the top, how many we have, segments on the bottom, so that we can see what the pattern looks like. How many triangles here?
2.
How many segments?
5.
1, 2, 3, 4, 5, everybody agree with that?
Yeah.
How many triangles here?
3.
3, how many segments?
7.
7, everybody agree with that?
Yeah.
See a pattern there?
Yep.
So for 4 triangles, what's it gonna go to? How many segments?
9.
9. For 5 triangles,
11.
11, because each time it's going up by 2 there. Suppose Adric makes n triangles. Make a conjecture about the number of segments he will need to make the triangles. So for, we had, so n triangles. This is where you gotta use your brain a little bit. For 1 triangle, how many segments?
3.
For 2,
5.
for 3,
7.
what's going on each time here?
Every one you go numbers, you're adding 2 segments.
You're adding 2 segments. So how are we gonna do that if n is the number of triangles? Can we just put n plus 2?
No.
That's not gonna work, is it? Because n is the number of
Triangle.
triangles.
So you do n
It's
plus
2
1
n
times
plus 2.
N plus 1 times 2. So what are you saying? Something
2.
like n plus 1 in parentheses times 2, is that what you mean? I'm trying to figure out what you're saying.
And that would that work?
I don't know, would that work?
No, because.
So n, let's try it out. N, if n is 1, 1 plus 1 is what?
2.
2. 2 times 2 is 4, so that doesn't work.
It's 2n plus
2n plus 1. See if that works. 2 times 1 is 2, plus 1 is,
1. 3.
so that worked there. 2 triangles, 2 times 2 is,
4.
plus 1 is 5. 2 times 3 is,
6.
plus 1.
7.
So if we had 50 triangles, could we figure out how many segments there are without trying to draw it?
100.
Yeah, because that'd be sort of hard to draw, wouldn't it? It probably wouldn't work. So we just plug in 50 right there, which is 2 times 50.
100.
100 plus 1,
101.
so there'd be 101 segments. So that would be our answer there. C. Compare the number of line segments to the number of points in each step of the pattern. How many more line segments than points will there be if Adric continues the pattern for 4 and 5? Extend the pattern to the conjecture and make a conjecture about it. So, how many points do we have here? 3, so I'm gonna write that like over here to the side. How many points here?
4.
How many here?
5.
So how many is it gonna be for 4?
6.
6. For 5?
7.
7. what can we say this, instead of 2 times n plus 1, what is it now? When you look at the number of triangles, you're just adding what? 2 each time, is that right? So it'd just be n plus 2, ignore that.
Okay.
You're just adding 2 to the number of triangles to get the total number of points. 4?
Yeah.
Problem 4. Say 11 over 2, is that what it said?
Mm-hmm.
5, 9 over 2, and 4.
They want us to write a conjecture and then find the next term. Let's find the next term first. Anybody figure out what we were doing here?
Everyone you add, you subtract 2.
Subtract 2,
Subtract a half.
subtract a half.
Oh, yeah.
Is that what we're doing, subtracting a half? You maybe could go that route. Might be an easier way. What if you did this? What if, instead of looking at all these as whole number, then fraction, whole number, then fraction, how could we make this a fraction?
I put a 1 under it.
Put a 1 under it. Now, we don't want a 1 under it because these all got 2's under it, so what could we make it?
Make it.
So you, if you want a 2 on the bottom, what do you gotta do to the top?
It's a change that you.
Multiply it by 2. So what do you end up with?
12.
Over,
2.
then here what would you end up with?
10
10 over 2. Here what would you end up with?
8.
8 over 2. You seeing the pattern now?
You're coming down half.
So what's the next one gonna be?
5.
If we're 8 over 2, if we went 12 over 2, 11 over
6
2,
over 2.
10 over 2, 9 over 2, 8 over 2,
7.
7 over 2 would be the next one. And the conjecture, the one that you guys said would work, what are you doing each time?
Down, subtracting a half.
Subtract 1/2 each time. That would be a good conjecture.
Subtracting a half each. Okay.
If you didn't grab the notes, grab them now. Start filling in what you need to fill in on this. Ethan, O, you still with us? You having a rough morning? Want me to make it rougher? Alright. So give me a few minutes and then I'll try to make it easier on you, alright?
Hey, Haley and Harley are called this year, or next year, hopefully I'll be up.
Hopefully.
Do you think you'll score more basketball than soccer?
That just being up doesn't mean that you
Probably
hit the
not.
net instead of the bars.
She'd be lucky to hit the bars.
She hits bars a bunch, that's what we're talking about here.
All you hit's bars.
Alright, a statement, anything that is either true or false, but not both. Give me a statement. What?
Your shirt is brown.
Write that down in your example there. Doesn't matter what it is.
Wait, but that is true.
It's true, but it could be, it doesn't matter. It's either true or false, one or the other.
Oh, okay, that's what you meant.
When they ask you to find the truth value of something, that's just a fancy way of telling whether the statement is true or
False.
false. So when they ask you that, don't make it harder than it is. They're just asking you to tell whether the statement is true or false. Another symbol. This symbol here sort of means not. I hate to sort of put that in or write that in there, but because there's many, it's almost like this symbol.
It looks like
What is this symbol?
opposite.
It's the opposite symbol. It's not supposed to be a negative symbol. It's supposed to be in math. It's actually the opposite of 2. Now they've taught you because they didn't think that you would understand it back in 4th grade or 5th grade when they started teaching you about negatives. They didn't think you'd understand, hey, we're talking about the opposite of it here. But that in math, that's exactly what it's supposed to say. So when you see something like this, and it's read 5 minus 2, it's actually saying 5 put together with the opposite of 2. All right, which is 3. That's sort of the way this symbol is. This symbol means not. So if I write something like this, that's read not dog. Right? It's just sort of the opposite of what it was.
Okay. It does look like
Right? It looks like part of a congruent sign, doesn't it? Because congruent sign, again, remember, has the equal to part with it. This doesn't have that equal to part. It's just the tilde part. Just that little curly Q thing there. When we see something like this, we're going to see a lot of this. This says not P. P is just some statement. I don't know what that statement is, and we're going to use it a lot. Because instead of writing out complete sentences all the time, they're going to try to make it easier on you and just put like not P, not Q, or R, whatever the statement is. That way you don't have to write out a whole statement like this one. Alright, so a lot of times you'll see something that'll just say not A, or it might just say B is your statement. Now we don't know what statement B is, so we can't tell whether it's true or false, but it's just some random statement, so that we don't have to write something out like my shirt is brown and keep writing out complete sentences all the time. Again, negation is using that little symbol, and it just sort of means not or the opposite of. Different books use different things. I can't remember for sure in this book. This is only second year with this book. The things that we have down there at the bottom, I can't remember if it uses those or not.
That's so
Yeah,
weird.
it does.
Oh.
It uses and.
It uses the upside, the tent and
The
the
AV, yeah.
Some books do, some books don't. All right, a compound statement, you put 2 statements together. My shirt is brown and my pants are brown. I don't know, whatever. All right. You put the 2 together. You either use an and or. When you have a conjunction that uses the word and. So something like a quadrilateral has 4 sides and a quadrilateral has 4 angles. First of all, is that true? Is the quadrilateral got 4 sides and 4 angles?
No. Yeah.
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 Yeah. Alright, so that's a true statement, and a lot of them you'll have to tell whether they're true or false. So that's a true statement. When it says and, we look at it and we say a quadrilateral has 4 sides. What if I changed this and said a quadrilateral has 4 sides and a quadrilateral has 3 angles?
No, it's not.
Is that true?
It's false.
But it's got 4 sides.
But and means it doesn't, it has to have both.
When you see and, you might want to write this in your notes there. Anytime you see the word and, both parts must be true. For the statement to be true, both parts have to be true. Whenever you see and. Alright? So if one part's false, then that means the whole thing is false. So both parts of the statement have to be true for that whole thing to be true. They'll use, sometimes they'll tell you this just says statement P and statement Q. They might write it out that way just to make it easy on themselves so they don't have to write out full sentences. And you may have to write out full sentences there. If P, they might tell you statement P stands for Joe is here. Who knows? Just making up something. And statement Q might stand for Tom is gone. And then you'll have to write out a sentence using the word and, where you'll say Joe is here and Tom is gone, and then decide whether that statement is true or false. This is the symbol for and. So this just says P and Q. Another way to shorten it up so you don't have to write so much. If that's the symbol for and, anybody have a guess what the symbol for or is?
Down here, a down one.
Looks like this. And I think that's probably on the next slide here, isn't it? Yeah.
It's down here.
So a conjunction uses the word and. A disjunction uses the word or. So unlike when Mason's sitting watching the Saturday morning cartoons and it comes on and it says, conjunction junction, what's your function? And he's sitting there bobbing his head and dancing around to the trains and stuff. Look at AJ back there laughing because he knows he's been sitting and watching. He probably watched him this past Saturday.
Yeah, I did. You can watch the UFC.
You watched what?
I watched the UFC. Oh, I was never allowed to watch cartoons when I was a kid.
What?
Dude,
So
you
you
can
cannot
watch
have a
UFC.
childhood.
Yeah.
What do you
That's
want?
a pretty cool childhood.
AJ, don't lie to me, because as soon as I started singing that song, you were back there with a big smile on your face, so I know you've seen it.
Cartoons are too
I've heard of it. I remember
I
it.
didn't watch it.
So, unlike that, in math class, unlike that cartoon, in math class, when you use the word or, it's not called a conjunction. It's called a disjunction. And is a conjunction, or is a disjunction.
Me too.
So let's make up a sentence with the word or in it. Somebody make me up a statement. We'll do 2 separate statements.
I'm gonna wear a shirt or a hoodie.
That's a good one.
Okay.
I remember it.
We'll wear socks or
No.
I'm not very real.
So we have this. These are our 2 statements. We got this statement, we got this statement. When you're looking at these, and you're going to have to decide whether they're true or false, what I like to do, whether it's the word and or in there, is I look at the first part. I am going to wear a shirt. Now, this is sort of a different one because can we really say whether that's true or false? Not really.
He's wearing a hoodie.
But, so we look at this and we decide whether this first part is true or if it's false. And we look at it and we decide if the second part is true or false. If this part's true and this part's false, and we have or in there, what's that tell us about the entire statement? It's a disjunction, so if it's one part's true and one part's false, what's that telling us? It's true. So with a disjunction, only one of the parts has to be true for the entire thing to be true. Think about it with this one. Cameron's wearing a hoodie, isn't he?
Yeah.
So did he lie to us? No, his whole statement there is a true statement. Now, if he said this, and we put the word and in there and made it a conjunction,
I'm wearing a shirt.
And all he's got on is a hoodie, then did he lie to us?
Yes.
Yes. So you gotta check both parts, see if they're true or false, and then decide whether you're dealing with a conjunction or a disjunction. Michael Riley, trouble?
No.
So focus. This symbol means or. So whenever you see that, it's telling you or. So this is just saying statement P or statement Q, statement P or statement Q. Again, just a shortened way to write it. Key thing here. Might want to write this down somewhere. If you're using the word or, how many parts have to be true? One part true. If you're using the word and,
All of them.
you gotta have both parts true for the whole thing to be true. Does that make sense? That's the key for all this stuff that we've done so far.
Can I use or and why?
In the same sentence?
Yeah. Like, can I have like,
No. No.
and hoodie or?
Well, then you got complete separate, now you got two different compound sentences.
Interesting.
Stuff to fill in on this, or is that already filled in for you?
It's already
It's already filled in?
Yeah, filled in.
So negation, again, the negation's just that little tilde, and the TP, or is the B. And is a conjunction, or is a disjunction. Make sure you know those symbols. Now a little harder stuff. Give you a second to write this down. This is probably a little more important than the other stuff. I'm gonna do a little more with this. Not anything to fill in on this one? No. There's none.
I'm still writing.
A conditional statement, I guarantee, final exam, this will be a question on there.
Okay.
A conditional statement, another name for a conditional statement is a if and then statement. Not just on the final exam, but probably on the next vocab test that we take, it'll say conditional statement. And if it says conditional statement, what's another name for it?
If and then.
If and then statement. So make sure you know that. In a conditional statement, it's going to have the word if at the beginning, the word then, this should be a comma. The part that's with the if is called the hypothesis. The part that's with the then is called the conclusion. So when we're looking at this, and you got to be real careful when you're doing this, I look at this example. What's the hypothesis? It is raining. Not the if. You don't put the if in the hypothesis, just the whatever's after that. So that's the hypothesis. Write that down there. That's the hypothesis. What's the conclusion?
The grass is wet.
The grass is wet. That's your conclusion. if stays as the first part, it's not actually part of the hypothesis, it's just what shows you where the hypothesis is, the then shows you where the conclusion is.
Don was saying such a good movie.
What's the, Branson? Not today, man.
It's a hypothesis.
What's the hypothesis in this case?
P is P.
So just the P is the hypothesis, what's the conclusion?
Q.
The Q. The last one, what's the hypothesis?
Two angles are vertical.
Two angles are vertical. What's the conclusion?
They're congruent.
They are congruent. Let's go back to the first one here. Is this a true or false statement? If it is raining, then the grass is wet.
That is true.
Is that true or false?
False. False.
False?
Yeah.
If it's false, then what you have to be able to do is give me a counterexample. Does anybody remember what a counterexample is from last class?
Something to back your answer up.
Something to back it up, something to show that it's false. So give me a counterexample.
If the grass is under, like,
Right, so maybe if the grass is under a tent or something, right? Then would that grass be wet?
no.
No.
And
The last one, if two angles are vertical, then they are congruent. Is that a true or false statement?
False.
So if we got two vertical angles, anybody remember what vertical angles are?
wait,
If I draw this picture, oops, that's supposed to be a 1.
do they add?
Which angles are vertical?
1 and 4 and 3 and
1 and 4 are vertical angles. What do you know about vertical angles?
They're congruent.
right.
They're always congruent to each other, right? So if they tell us that we have two vertical angles, do we then know that those two angles have to be congruent to each other?
2. Yes.
So is this a true or false statement?
True.
It's true. As a matter of fact, this was our first theorem that we talked about, all right? And what do we know about theorems? They have to be true, all right? They have to be proven true, but somebody else has proven them true, and so they are true. So this would be a true statement. What if we turned it around and we said, if two angles are congruent, then they are vertical?
Yes.
That is false. Wait, if what?
If two angles are congruent,
Oh, no.
then they are vertical.
Because you can have 2 adjacent angles.
As a matter of fact, we did this problem last time where I drew this picture,
Perpendicular angles.
and those two angles were congruent, but are they vertical? No. So if we turned it around, that statement doesn't always have to be true, and we could show a counterexample of that.
Couldn't you do like a perpendicular line too?
Yeah, you could. So if we did two perpendicular lines, this angle's a right angle, that angle's a right angle, they're congruent to each other, but are they vertical angles?
No.
No.
No. Not.
All right, we're gonna fill this in. Once we fill it in, we're gonna write some stuff down at the bottom here to show you. Or actually, first we're gonna write stuff down at the bottom. Converse. The converse of a statement, all we're doing with converse, inverse, and contrapositive is we're taking a compound statement, an if and then statement, and we're moving stuff around. All right? These are not difficult, but I like them because they're easy for me to grade and stuff as far as this chapter goes. What the converse does, it switches the hypothesis and conclusion. It switches the hypothesis and the conclusion. Ethan, are you still with us? Don't lie to me.
I'm sorry for laughing.
It's all right.
Don't lie to me.
These are very simple. This chapter, AJ, is not real easy, but these are pretty simple if you focus right now. So all it does is switches the hypothesis and the conclusion. That's what the converse of a statement is. What's my hypothesis in this original statement right here? Q. So underneath that, right, hypothesis. What's my conclusion? P. Ignore that. The if is going to stay in the same spot. The then's going to stay in the same spot. And what's the converse do?
Flip the Q and P.
Switches the Q and the P. So, hang on. Do me a favor, because I messed this up. This already did the converse. I didn't read my notes well enough. Do this. Don't erase everything. Do this. Mark this out on your paper. That's not gonna help.
Yeah, it is, because then we can just go.
All right, write this in. If Q, then P. Write that in as your original statement. I messed this all up. I gotta start reading stuff, I guess.
Wait, as our top statement?
Yeah,
Just your friend.
it's getting a rush. Don't pay attention. So what's it gonna say? What's the converse gonna say?
P.
If P, then
Q.
all it does is switch it around. Did I confuse everybody? Hannah, did I completely screw that all up and confuse you to death? Don't lie to me.
Say yes.
Did I confuse you?
Say yes.
We're gonna go back to
Yes.
first.
Yeah, I know, that messes everything up out of that. I'm trying to come up with it in my mind while I'm wasting time here, Jacob. Do me another favor, mark this out.
Okay.
Mark this out.
Yeah.
My pencil's not dark enough for this.
If you scratch all through it and you can't remember, Kellen, that, hey, I marked this out, don't look at it, then it ain't got nothing to do with your pencil not being dark enough.
I get confused sometimes, Mr. Ebersole. Like that one time in the fire when I walked away from my parents,
What?
and then I got hid, and then I hid in the coat rack.
No.
Coat rack.
What'd you
I
say?
ain't said no.
Say it again.
No.
No, it was
The
my parents.
inverse.
Anyway.
The inverse. Whatever you're doing, any of these three, you're always going back to the original statement. So this is the original statement. This is our original statement, even though it wasn't supposed to have been. But we've switched it around. I messed it up enough now that it's going to be. You always go back to that to do it. So don't look back at the converse to do the inverse or the contrapositive.
You all right?
Always going back to the original.
If you the P.
The inverse does this. Negates the hypothesis and negates the conclusion. Now what that means to negate it, that's that little tilde symbol, all right? But what it's actually doing is just putting not in there. So if my hypothesis is it is raining, and I want to stick not in there, what's it going to say? It is not raining. That's what it does. So if my original statement is if Q then P,
If not Q,
if not Q, then
not P.
not P. That's all the inverse does to it. Leaves it in the same order as it started out in, It just negates both parts. Anybody have a guess what the contrapositive does to a statement?
Is it like opposite thing?
Keeps everything the same.
That wouldn't do anything.
Is it the
What'd this one do?
switches?
Switch the hypothesis and the conclusion, what'd this one do?
Negates the hypothesis.
Negates the two,
It's both.
it does both of them.
Oh.
So, it does both. So in other words, it switches and negates. So if we go back to the original sentence, I got my if as the first part, that's always going to be the first part. I got my then as the second part. What's the contrapositive going to say?
If not
If
P,
not P,
If not P, good,
then not Q.
then not Q. Converse, inverse, contrapositive. Now Elizabeth, as long as I allow you to use your notes for a while, should you be able to get those right?
Yeah.
Not hard, you should be able to just look at them and see what you're doing, right? They're not difficult, just might be a little writing. All right, so on this, is this on your notes somewhere?
No.
Yeah, it's on there. Oh, it is. France. A polygon with four sides is a quadrilateral. First thing we want to do, we want to write this as an if and then statement. So first thing we're going to write, if, how can we make this into an if and then statement? And this is usually the hardest thing that students have when we're doing these things, is making something into an if and then statement.
If it's a polygon, then it has four sides.
No.
Oh, if it's a quadrilateral, it has four sides.
What?
Maybe.
If it's a polygon with four sides, it's a quadrilateral.
Alright, so if shape is polygon, and you're gonna notice my English not very good. Alright? Do you think I'm going to take off for your English? No, not as long as it makes some kind of sense. Alright? So if a shape is polygon with four sides, what's the rest of my sentence going to be? Then is a quadrilateral. This is my original sentence. So Riley's happy already that he's got to write sentences in math class.
It's not that bad, we don't have to use real English.
Right. I'm not grading on your grammar or your punctuation or any of that stuff. Before we go any farther, we want to know, first, is this a true statement or a false statement?
true statement.
It's true, so out here at the end, write true. Then the next thing we need to do, before we can write the converse, inverse, contrapositive, we need to know what the hypothesis is, what the conclusion is. Somebody tell me the hypothesis of this.
A shape with, if
A polygon with four sides.
So that's your hypothesis, write that. Write hypothesis, underline that part, write hypothesis with it somehow, so you know that that's your hypothesis. What's the conclusion?
It's a quadrilateral.
That's the conclusion. So now we have all that. We want to write the converse, the inverse, contrapositive. For converse, usually for converse, I'll abbreviate it just this. Because we're already writing a bunch, so we don't wanna have to write any more than we absolutely have to. What's the converse? Looking back at your notes there, what's the converse do right above? What's the converse do to the statement?
Switches the hypothesis.
Switches the two. Now this, I do want it to make sense. So what are we gonna say?
If it's a quadrilateral, what happens?
If what is a quadrilateral?
If the shape.
Alright, you got to remember in English class, you usually want your subject to be in the first part of the sentence. So that we need, even though this is part of the hypothesis, it needs to stay as part, that first part. So if shape is what?
Quadrilateral.
If shape is a quadrilateral.
Is quadrilateral.
There.
Then what?
Then it was a polygon with 4 sides.
Yeah, too much.
Then four-sided polygon.
Alright, so then has 4 sides. Is that good enough?
Close.
So if a shape is a quadrilateral, then it's a polygon with, I probably should have put polygon in there, but oh well. Then it's a polygon with 4 sides. Is that true or false?
That is true.
Everybody agree with Michael on that, it's true?
Yeah.
So write true out there next to it. Next one, what are we gonna write next?
Inverse.
The inverse. Looking back, what's the inverse do?
Makes it not.
So it goes back to the original statement and just sort of makes it not in both parts, right? Does sort of the opposite in both parts. So what's it gonna say?
If a shape is not a quadrilateral, oh wait, if a shape is not a polygon, does it have 4 sides? How would you say this? I
If
give
a
up.
shape is not a polygon with 4 sides, it's not a quadrilateral.
Right? So if shape is not what?
A polygon.
A polygon. Not a polygon.
Then
Nah, we missed something.
with 4
With
sides.
4
With 4 sides. Then is not quadrilateral. Pen is going nuts. If a shape is not a polygon with 4 sides, so we got some shape. And these sort of get hard to decide whether they're true or false sometimes. So we got some shape. And
Not a polygon.
it doesn't have 4 sides, right? Then it is not a quadrilateral. Is that a true or false statement?
True.
That's true? Everybody agree with that?
Yeah.
You gotta stop and think some of the time. True. What's the last one we got to write? Contrapositive? Contrapositive?
I didn't even try, so.
What's the contrapositive do? Look back at your notes. What's it do to the statement?
It flips both things, switches and negates.
So it negates it and it switches them around, right? So what's it gonna say?
If shape
If shape
is not quadrilateral.
is not quadrilateral. Everybody agree with that so far?
Yeah.
Shape is not a quadrilateral,
Then it is not a polygon with 4 sides.
then it is not polygon with 4 sides. Now, as we do some of this, especially when we're doing the more of the geometry stuff, this one didn't really work out real well. But when we're writing out stuff like congruent and angle and stuff like that, do we really want to write out all those words?
No.
Use your symbols to make it shorter so you don't have to write so much. Alright? Let's go back to this real quick. If a shape is not a quadrilateral, so I have this shape in my hand, you see it?
No. Yeah.
No. I'm telling you, it's not a quadrilateral. Alright? Then it is not a polygon with 4 sides. Is that a true or false statement?
True, it's true.
That's true. Alright, I'll also tell you this, you might want to jot this down somewhere there in your notes. If the original statement is true, because the contrapositive is sort of hard, it's real wordy sometimes, and it's hard to understand. If the original statement is true, usually the contrapositive is also true. So if Cameron's not sure about the contrapositive, because it's too wordy and he can't understand it, but the original statement was true, a good guess would be that the contrapositive is also true.
It's kinda like a double negative.
Huh?
Contrapositive is kinda like a double negative.
Yeah. Right. What do you got on the next page? You got to fill in this. Yeah. Fill in some of this. I'll give you a second.
My pencil sucks so bad.
So grab a different one up front. Some up there in that cup. Cup right up here. Put that one in
I
there.
just now noticed that this was a thing. I had never seen that before.
Mason, is this too much logical thinking for your brain? Most teenagers it is.
23, right?
I don't think there is. I think they're seeing things.
Possibly. I would be true.
No, it was like you.
I'll go back to that in a second. 23 is not on there.
It is on the paper.
It is in the paper.
Ah, you guys are seeing it though.
Body and it scared me.
You're behind, man.
I didn't realize, I didn't realize.
You're a little late.
I was
All right. You're a little late. Implies. If you see just a single arrow like this, it means implies. So write this down in your notes there. It might say something like,
Dog. Car.
so if you see a dog, it implies that there's going to be a bark. All right, something like that. All right, I'm just making up stuff. This doesn't. Does this have to be a true statement? No, I'm just making up stuff. Biconditional. Biconditional would say something like this.
Dog.
So now what it's saying when it puts that double arrow in there,
If you ever
dog implies bark, and if you hear a bark, it implies that there is a dog. So it works both ways.
I just said dark and
All right.
dog.
I said that.
Equivalent statements. Two statements are considered equivalent. This is sort of something dumb that we don't deal with a whole lot. But if two statements are considered equivalent, then that just means that either they're both true or they're both false. Biconditional. A statement is considered biconditional if the statement is true and its converse is true. Write this down with biconditional. All definitions are biconditional. All definitions are biconditional. So if you look up a definition in the dictionary, it's going to be true and its converse is going to be true. I think we talked about this earlier this year. I threw it back on here. IFF, I didn't spell this wrong. That means if and only if. So if I say something like, a polygon is a square if and only if it has 4 equal sides and 4 right angles. What if I just said a polygon is a square if and only if it has 4 equal sides? Is that a true statement? No. Are there other polygons that have 4 equal sides but aren't squares? Yeah. All right, open up your books to page 161. We got about 10 minutes. Page 161 first. Books open. We'll go back to the homework here in a few minutes.
Wasn't this the page that we did this up?
Maybe.
116, no, that was 167.
Yeah.
161. Looking at the examples on 161. You turn it around. Look at example 1. Use the statements to write a compound statement for each conjunction. Then find the truth value. And it says explain the reason. I'm not so much concerned about that. Part A says what?
The figure is
What's A tell us?
P and R.
P and R?
Yeah.
Now this is what you're going to have to do on some of these. They tell you a statement for P. Okay? What do they tell you that the statement for P is?
Figure is a trapezoid.
Figure is a trapezoid?
Yeah.
So you're going to write that down. Figure is a trapezoid. Now you don't have to do it on this example. I'm just trying to show you here how to do it. Right? Then we're going to put what in there? And. Because it's a conjunction this time, right?
Yeah.
What's the statement for R that they tell you?
The figure has 4 right angles.
And this is where we want to shorten it up as much as we possibly can, right? And they want us to decide whether this is true. If we're using and, if it's a conjunction, what has to be true for that statement to be true? Both of them have to be true. So figure is a trapezoid. True or false?
True.
False.
Just go.
Oh. False.
I don't know. Is it true or false?
It's false. That's a square.
That is a square.
So that's false.
Yep.
The figure has 4 right angles.
That is true.
That's true. So is this whole statement true or false?
False.
False. Does everybody see what you're going to have to do on those? So it's not P and R, it's they tell you a statement for P, they tell you a statement for R, and you got to write it out as a sentence.
Okay.
And then you're going to tell whether that whole thing is true or false. Let's do B. It looks like it's a little harder. What's it say?
P or Q? Is that or? I don't
It's
remember.
not P
It's and.
and it's like a carrot.
Is that one?
Yeah.
Q?
That's and, right?
I don't know. Is that and?
Yes.
Okay.
So not P and Q. So what's the statement for P?
The figure is a
Not
trapezoid.
a trapezoid.
So we're going to say figure
It's not.
is not a trapezoid. What's the symbol? And what's the statement for Q?
The figure has 4 congruent sides.
Figure has 4 congruent sides. First part of this, true or false?
True.
That's true, everybody agrees with that?
Yeah.
Second part, true or false?
True.
And both parts are true, so what's that tell us about the whole statement?
True.
The whole thing is true. That's what you gotta do, you gotta write it out. Probably, in your books, is there gonna be room to write this stuff in there?
Nope.
Probably not, use a separate sheet of paper. Like I said, I was gonna start making you do it on a separate sheet of paper here pretty soon, right? Said that a couple weeks ago. This is a good time to start. Do your homework on a separate sheet of paper this time. Right, because it will not fit in the book.
Do you put the answers in the book?
No, just do it, put the answers on the separate sheet, that's what I'll check. Alright?
Been doing that since day one.
Does that make sense? That's good, Luke, yeah, that's probably what we should have done.
I don't know.
No, I'm just trying to see which one I want to do. Flip over to the next page, example 2 there at the top. Example 2 at the top. P. So we're gonna do this one, P with that symbol, not R. And we wanna tell whether it's true or false. What's the statement for P? I guess I should probably draw this picture, shouldn't I? Somebody help me out. Which way does the other ray go? Left or right? Right, this way?
Left,
No,
left,
left.
Michael. Yeah. Look at my lips.
What's this letter?
A. C.
They tell us anything else in the picture?
Yeah, there's 2 lines between A and B, and then there's B. There's a line.
There's a line.
A, B, and then B, D.
So what's that tell us about those two
They're
statements?
congruent.
They're congruent. Is that all they tell us?
Yeah.
What statement P say?
Angle ABC and angle CBD complementary.
Complementary.
Add them to 180.
All right. What's this symbol mean?
90.
What's this symbol mean?
Or.
Not R. What's the R statement?
Segment A, B,
So we look at this.
Or.
Angle ABC and angle CBD, this angle and this angle are complementary, true or false?
False.
False, because they're not complementary, they're what? Supplementary. So that's part's false. Segment AB is congruent to segment BD, true or false?
True.
True.
True, but it's the not, so.
Now, it was the not?
Yeah, it's
Oh,
not.
okay.
Oh, so it's not congruent, so that makes it what?
False.
False, my fault, I didn't see the not. This part's false, this part's false, what's that tell us about the entire statement?
It's false.
Look over at the next page. Just real quickly. Example 3, part B. Another performance will be scheduled if the first one is sold out. We want to write that as an if and then statement. So if what?
The performance is sold out.
Now you're turning it around.
If no.
So
All the tickets are
can
sold.
we turn it around like that?
Yeah.
You got to be careful sometimes. but this one probably so. If performance sold out, then what?
There will be another
Then another
performance.
performance. This part's called the what? Hypothesis. This part's called the conclusion. You ought to do that. You got the assignment there on the page. Still don't see where you guys see.
It was on our paper.
There's a space after the 23 comma, the 26 comma. That's where 3 was.
Right there.
Only one point three there.
Nope.
No,
Two.